Jump straight into coding a snake game with JavaScript, perfect for beginners. Let's create something cool fast. Today we're coding using the free online editor at editor.p5js.org. We're starting with a canvas of 800 pixels wide by 500 pixels high. Let's change the background color to light blue. Okay, let's run our code by pressing the play button. Let's add variables for the snake: resolution, food, width, and height at the top. The resolution will be the size of each grid square in our game, set to 20. This will make our graphics nice and chunky, just like the original game. To ensure we maintain this very blocky layout, we'll divide our canvas into a grid of much larger groups of pixels. We'll calculate the width and height of the game grid by dividing the canvas width and height by the resolution we've selected. In this case, groups of 20 pixels. Then we'll use the floor function to ensure these values are whole numbers. Let's slow down the game by setting the frame rate to 10, making it easier to play, and create a new snake object to get our snake ready for the game. We need to define the snake class we just used. Let's create an empty constructor for now, as well as a placeholder update and show method. Before I forget, let's scale everything by the resolution, making it easier to work with our grid. By adding the scale function with the resolution as a parameter right at the start of the draw function. We'll now add 2 lines in the draw function to update and display the snake every time the screen refreshes. This won't do anything yet because we haven't implemented the logic, but we're just getting everything set up for now. Let's start filling out the snake class now. We need to store the snake's body as it grows, so we'll use an array for that. Each item in the array will be a vector, which is just a fancy way of saying an X and Y coordinate. We'll start the snake in the middle of the screen by setting X to half the screen's width and Y to half the screen's height. Let's also create 2 variables to track which direction the snake is heading on the X and Y axis at any given moment. We'll talk more about these later on. We can now start to make our snake visible by adding a loop in the show method to draw each segment of the snake's body. Inside the loop, we use the fill method to set the color to green and the no-stroke method to remove the border. Then, we draw each part of the snake's body using the rectangle method, setting its position on the grid with the vector coordinates for that segment of the body. We also set both width and height to 1, making sure it fits nicely in our grid system. We now have a very tiny snake in the middle of the screen, but it can't move. Let's fix that. We're adding a key pressed function that will get called anytime a key is pressed. If the user presses the left arrow, we want to move in the left direction on the x-axis, or in a negative direction, if that makes sense. We'll do this by calling the setDirection method on our snake object. If the user presses the right arrow, we want to move to the right, or in a positive direction. The down and up arrows will move our snake on the y-axis in a similar way. We need to implement the setDirection method now, the one we just used in the keyPressed function. It will simply just set the x direction and y direction variables. To get our snake to actually move, we need to implement the update method. The first thing we want to do is grab a copy of the head of our snake. In other words, the vector at the very end of our array. We'll then shift each object in our array down 1 spot. This means the vector in the very first position will effectively be deleted. This was the oldest part of our snake's body, and the snake is now no longer at that location. Now we can modify the copy we made of the snake's head and add the X or Y direction the user last wanted to move in. We'll then push this updated head back onto the body so that it's again the last item in our array. Let's add a grow method, which we'll use once we've introduced the concept of food for our snake to eat. To make the snake grow, we'll simply duplicate the head of our snake and push it onto our body array, making it 1 segment longer. Let's create some food inside our game canvas. Inside our setup function, we'll call a new function called foodLocation, which we'll need to define. This function will choose a random X and Y location, and then update the food variable to point to that location. Before we go on, I want to quickly add the definitions for the 2 final methods of our snake class: endGame and eat. We'll come back and implement these important functions in a minute. Before we do, let's finish the draw method. First, every time we draw the screen, we want to check if the snake can eat the food. If it can, we'll eat the food and add some new food in a new random location. We also want to check if it's the end of the game. If it is, we'll fill the screen with red paint and stop the draw loop. If it's not the end of the game, we'll draw the food on the canvas. We do this by removing the stroke, setting the fill color to blue, and drawing a rectangle at the food's location, making the food appear as a blue square on the grid. While I think of it, let's also update the key pressed function to allow the user to restart the game if it has ended. We'll simply call our setup function again and start the draw loop. Okay, let's finally start working on the eat function. The first thing we want to do is get the X and Y coordinates of the head of our snake so that we can compare it to the X and Y coordinates of the food. The coordinates of the food have been passed to this method by the pos, or position, parameter. If the snake's head and the food coordinates match, we'll call the snake's grow method and return true. This will cause the draw function to call the food location function, selecting a new food location. Let's take a look to see if our snake can now grow. Nice. The final thing we need to do is implement the end game method. Again, we start off by getting the X and Y coordinates of the head of our snake. If the head of the snake has gone outside of our canvas, it's the end of the game, so we can return true. Finally, we also want to see if the snake has eaten itself. We'll do this by looping through every part of the snake's body, except for the head, and checking if that particular segment of the body intersects with the snake's head. We'll return true if so. Our project is now finished. If you want to learn to code in bite-sized steps, like this video and subscribe. Until next time, happy coding.